स्टार्ट करते हैं। सो व्हाट वी डिस्कस यस्टरडे माय फ्रेंड्स, कल हम लोगों ने क्या डिस्कस किया था? यस्टरडे वी डिस्कस अबाउट रेनॉल्ड्स नंबर। लेट अस हैव द क्विक रिवीजन बेटा, लेट अस हैव द क्विक रिवीजन ऑफ रेनॉल्ड्स नंबर, देन वी विल बी मूविंग फॉरवर्ड। रेनॉल्ड्स नंबर in bracket RE. This is what we have discussed yesterday. Do you remember what is the basic formula of Reynolds number I have given you, my friends? What is the basic formula of Reynolds number I have given you? Look at here. How we started? We started Reynolds number is equal to what? Inertia forces divided by what? Inertia forces divided by what? Viscous forces. Inertia forces divided by viscous forces. And you know, finally after solving, I was getting like this. After solving, I was getting like this: rho capital V capital L, rho VL by mu. After solving, I was getting rho capital V capital L by mu. And of course, I know this V is equal to average velocity. This V is equal to average velocity for closed conduit flow, for the internal flow. And this V is equal to U infinite. V is equal to U infinite for flow over plate. What is this capital L? This capital L is the characteristic dimension. For internal flow, this was equal to what? 4 into area of cross section divided by wetted parameter. And whereas on the other hand, for flow over plate, for the external flow, it was coming equal to X. For the flow over plate, basically the distance from the leading edge. Now listen carefully, my friends. For flow through pipe, the formula of Reynolds number was coming rho average velocity d by mu. Now listen carefully. What is the main function of Reynolds number? Reynolds number हमको क्या बताता है रे बाबा? What Reynolds number will be telling us? Can you tell me what Reynolds number will be telling us? Anyone in the class can tell me what Reynolds number will be telling us? Type in chat box रे बाबा. Yes. Excellent. Yes Pritam, very good beta. Yes. Excellent Raju. Excellent beta. Excellent Raju. Satabdeep, wow. Ramchandran, very good beta. Nagasai, very good. Arjun, excellent beta. Mahesh, very good. Excellent. Reddy Sekhar, very good beta. Very good. Okay. What about other? Sanjana, very good beta. Now can you tell me what is the application of Reynolds number? I'm waiting. Yes, it will be telling us about the type of flow. ये हमको क्या बताने वाला? It will be telling us whether the flow is laminar flow or turbulent flow. तो देखो बेटा ध्यान से, listen carefully. If the Reynolds number is less than equal to 2300, if the Reynolds number is less than equal to 2300, then we will be saying the flow is laminar flow. And if the Reynolds number is more than equal to 4000, this is for flow through pipe only. I'm talking about flow through pipe only. Then the flow will be what? Turbulent flow. Excellent. अब देखना बेटा, sometimes for easy calculation, what we do, we assume 2300 is nearly equal to 2000, so that we will be having easy calculation. So most of the times you will be seeing in the books, if the Reynolds number is less than equal to 2000, the flow is laminar flow, and if the Reynolds number is more than 4000, then the flow is what? Turbulent flow. In between you are having transition zone. Remember, whatever I have discussed, that is valid only and only flow through pipe. Yes, ये दोनों के दोनों जो मैंने आपको बताए हैं, they are valid only for flow through pipe. You cannot apply for any other case. Okay, I hope everyone is clear. This is what I have discussed for flow through pipe. Fine. Excellent. Satya Prakash, welcome beta. Now listen carefully. Now I'm going to discuss one beautiful concept of fully developed flow. Anyone in the class can tell me बेटा, what is the meaning of fully developed flow? कोई मुझे बता सकता है बेटा? Anyone in the class can tell me what is fully developed flow? बोलिए बेटा क्या होता है फुल्ली डेवलप फ्लो? आई एम गिविंग यू चांस, प्लीज आंसर मी बेटा, प्लीज आंसर मी. व्हाट इज द मीनिंग ऑफ फुल्ली डेवलप फ्लो? प्लीज 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 respond. Please tell me what is fully developed flow beta. What is the meaning of fully developed flow? Please tell me. Please tell me beta, what is the meaning of fully developed flow? बोलिए बेटा what is the meaning of fully developed flow? Please answer me. Please answer me beta. What is the meaning of fully developed flow? I want everyone to answer. I want everyone to answer. बोलिए what is the meaning of fully developed flow? Tell me beta, what is the meaning of fully developed flow? Answer me. Answer me. Now listen carefully. Listen carefully my friends. Let us suppose I'm having some pipeline. Let us suppose, you can see, observe my friends, you can observe with this black ink. Excellent, excellent Pritham. Very good, very good. Very good beta Ajay. Very good beta Omkar. Excellent beta. Excellent. Very good my friends. Very good. Now let us suppose this is some pipe. ये मान लीजिए पाइप है and let us suppose this is center line. Let me say this is center line. This green one is center line. अब ध्यान से देखना बेटा. Now listen carefully. बिल्कुल ध्यान से देखना. When the fluid is entering the pipe, when the fluid is entering the pipe, listen carefully whatever I am saying. जब fluid pipe में enter करता है, then the velocity profile will not be well defined. Velocity profile well defined नहीं होती है. And the reason, look at here, the length of the pipe which is required for getting the velocity profile to be well defined is known as entrance length. And the reason up to which I am not having a well defined velocity profile is known as a developing region. So what I am trying to tell you is, whenever the fluid is entering the pipe, initially the velocity profile will not be well defined. It will require some reason. It will require some length of the pipe to become well defined. So the reason which is required to become well defined is known as developing region. The length of pipe which is required to become well defined velocity profile is known as entrance length. देखो बेटा, look at here. I will try to make you understand. Let us suppose I'm talking about here. And if you see the velocity profile, let me say the velocity profile is like this. Let me say the velocity profile is something like this. It is not well defined. Look at here. The fluid particle which is here is having zero velocity. The fluid particle which is here, it is having some random velocity. It is having this much velocity. The fluid particle which is here is having this velocity. The fluid particle which is here is having this velocity. And it will keep on changing within this developing region. This velocity profile, whatever I have represented right now, it will keep on changing beta. So this region up to which the velocity profile is not well defined is known as a developing region. That means ये वाला region है, इससे पहले मैं मान रहा हूँ बेटा. Let's suppose this region is a developing region. यहाँ तक आपका defined नहीं है बेटा. Velocity profile is not well defined. Let me call it developing region. And this length of the pipe up to where I am having developing region is known as entrance length. This is basically the entrance length beta. Let me represent by LE. Entrance length. Now look at here. Once the fluid is entering, or once the fluid is crossing this developing region, now the fluid will be having well defined velocity profile. I will be telling you what I am trying to tell you is, look at here. Let us suppose I am here. Let me see at this cross section. Now what will happen? The fluid particles now, they will be having well defined velocity profile. they will be having well defined velocity profile, maybe something like this. They will be having well defined velocity profile, maybe something like this, maybe something like this. Now please observe, please observe, please observe carefully beta. Now look at here, now look at here, these are the fluid particles. You see at this cross section or this cross section, doesn't matter. आप ये वाले क्रॉस सेक्शन पे देखिए, whether you see at this cross section or you see at this cross section, you will be having the same well defined velocity profile. You will be having the same well defined velocity profile. You will be having the same well defined velocity profile. And this region is known as fully developed region. Fully developed region. Fully developed region. Fully developed region. So I'm talking about this region, fully developed region. In this fully developed region, you will be having the fully developed flow. Means you will be having the well defined velocity profile. Now look at here, try to understand what I'm saying. Try to understand what I'm saying. Please listen carefully. बिल्कुल ध्यान से सुनना बेटा. Whenever I'm having fully developed flow, the fluid particles will be moving along the streamline only. They will not move in any radial direction. कहने का मतलब है, what I'm trying to tell you is, मान लो ये वाला fluid पकड़ लो. Let's suppose I'm talking about this fluid particle. This fluid particle will be moving in this direction only. This fluid particle will be moving in this direction only. This fluid particle cannot move in this direction or maybe perpendicular to the screen. मैं आपको एक एग्जांपल देता हूं बेटा, मैं आपको एक एग्जांपल देता हूं. लुक एट हियर. यस 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 चंदन, मैं आपको एक एग्जांपल देता हूं बेटा. आप देखिए प्लीज. लेट अस सपोज दिस इज द फ्लूइड पार्टिकल. बेटा ध्यान से देखना. लेट अस सपोज दिस इज द फ्लूइड पार्टिकल. आर यू एबल टू अंडरस्टैंड? आर यू एबल टू सी? अब देखो, this fluid particle will keep on moving in streamline direction only. Let us suppose this is x direction beta. Let us suppose this is x direction. Let us suppose this is x direction. So the fluid particle will be moving in x direction only. Fluid particle will be moving in x direction only. It will not move in y direction. It will not move in y direction, or it will not move in z direction. The fluid particle will be moving only and only in x direction. Fluid particle will be moving only and only in x direction. I hope you are clear. I hope. एक बार आपको डायरेक्शन बनाकर दिखाता हूं बेटा, then it will be more clear to you. Let me try to represent the directions, then it will be more clear to you. Let us suppose this is x direction. Let us suppose this is y direction. Let us suppose this is z direction. Fine. This is your x direction. This is your y direction. This is your z direction. Okay. So the fluid particle will be, if the flow is taking place in x direction, then the fluid particle in fully developed region, fluid particle will be moving in x direction only. It cannot move in y direction, or it cannot move in z direction. Is it clear to everyone? Is it clear to everyone? Is it clear to everyone? Now listen carefully. If the fluid particle is moving only in x direction, what is the component of velocity in x direction beta? Anyone in the class? What is the component of velocity in x direction? U. What is the component of velocity in y direction? Small v. What is the component of velocity in z direction? Small w. Now listen carefully. If the fluid particle is moving only and only in x direction in the flow direction, can I say u cannot be 0? Array, fluid particle is moving in x direction now, so there should be x direction velocity. But fluid particle is not moving in y direction. Fluid particle is not moving in z direction. So can I say small v is 0, small w is 0? Bolo re baba, bolo re baba. Are you clear till here? Are you clear till here? If I am having fully developed flow in fully developed region, then u won't be 0. Why you won't be 0? Because I'm assuming the flow is taking place, because I'm assuming flow is taking place in x direction. If the flow is taking place in x direction, in that direction I will be having the velocity, but in other direction I will not have any velocity. Excellent, excellent, very good my friends. If you are clear till here, now I will be giving you one more example. ध्यान से देखना बेटा, प्लीज ऑब्जर्व, प्लीज ऑब्जर्व, प्लीज ऑब्जर्व. लेट मी से this fluid particle is having the velocity of 5 meter per second. Let me say this fluid particle is having the velocity of 3 meter per second. Of course this fluid particle will be having the velocity of 5 meter per second. This fluid particle will be having the velocity of 3 meter per second. अब ध्यान से देखना बेटा. Now listen carefully. Are you able to understand what I'm saying? Look at here. Can I say one thing? In x direction, in x direction, in x direction, x direction velocity is not changing. अरे देखो, देखो, one fluid particle I am having here, it is having the velocity of 5 meter per second. Another fluid particle I am having here, this fluid particle is also having the velocity of 5 meter per second. So can I say in x direction the velocity is not changing? आपको example देता हूं बेटा. देखो ध्यान से, ये दोनों फ्लूइड पार्टिकल है सेंटर लाइन पर. These two fluid particles are at center line. These two fluid particles are at center line. This fluid particle is moving with the velocity of 5 meter per second. This fluid particle is also moving with the velocity of 5 meter per second. So can I say in x direction? Can I say in x direction the velocity, the x direction velocity is not changing? Can I say in x direction velocity is not changing? What is the meaning of this? The meaning is dou u by dou x is 0, because in x direction velocity is not changing. अब ध्यान से देखना बेटा. Now listen carefully. This is the center line fluid particle. What is the velocity of center line fluid particle? I have given you 5 meter per second. ये उसके ऊपर वाला fluid particle है. This is the fluid particle which is above it in y direction. ये फ्लूइड पार्टिकल ऊपर वाला फ्लूइड पार्टिकल है. व्हाट इज द वेलोसिटी ऑफ दिस फ्लूइड पार्टिकल बेटा? व्हाट इज द वेलोसिटी ऑफ दिस फ्लूइड पार्टिकल? 3 मीटर पर सेकंड. नाउ दिस फ्लूइड पार्टिकल इज मूविंग विद द 5 मीटर पर सेकंड. दिस फ्लूइड पार्टिकल इज मूविंग विद 3 मीटर पर सेकंड. सो कैन आई से व्हेन आई एम मूविंग इन y डायरेक्शन, कैन आई से व्हेन आई एम मूविंग इन y डायरेक्शन द x डायरेक्शन वेलोसिटी इज चेंजिंग? Array, look at here. If I am moving in y direction, this fluid particle is having 5 meter per second. This fluid particle is having 3 meter per second. So can I say in y direction, x direction velocity is changing? That means dou u by dou y is not 0. Similarly, perpendicular to the screen. अपने screen के perpendicular में देखो. This is the fluid particle which is at center line. This is beside it in z direction. In z direction, let me say I am taking another fluid particle. यहाँ पर ले लिया. ये वाला फ्लूइड पार्टिकल बेटा 5 मीटर पर सेकंड के स्पीड से चल रहा है. दिस फ्लूइड पार्टिकल इज मूविंग एट 3 मीटर पर सेकंड. कैन आई से द वेलोसिटी इज चेंजिंग इन जेड डायरेक्शन आल्सो? कैन आई से एक्स डायरेक्शन वेलोसिटी इज चेंजिंग इन जेड डायरेक्शन आल्सो? 100%. इसका मतलब क्या हो गया? यस 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 यस, एक्सीलेंट, यस. सो कैन आई राइट वन थिंग बेटा? इफ यू आर क्लियर विद दिस, if you are clear with this, can you confirm me this? Can I say dou u by dou x is 0, but 100% dou u by dou y is non-zero, dou u by dou y is non-zero, and dou u by dou z is also non-zero? Can I say this? ये बताओ बेटा, are you clear with all these things? Whatever I have written, are you clear with this? ये जो मैंने लिखा है for fully developed flow, are you clear with this? अगर ये आपको समझ में आ गया, you are able to understand one of the difficult concept. If you are able to understand this, then you are able to understand one of the difficult concept of fluid mechanics. अगर ये आपको समझ में आ जाता है, then you are able to understand one of the difficult concept of fluid mechanics. Why in fully developed flow we are having u non-zero but v and w 0? Why in fully developed flow we are having dou u by dou x 0 but dou u by dou y non-zero, dou u by dou z non-zero? Are you able to understand? Excellent. बेटा जेड डायरेक्शन में भी तो वही होगा ना ओमकार. In z direction also I will be having same thing ना. This is the fluid particle which is moving with 5 meter per second. It is at the center line. ये center line से थोड़ा हट कर है. This fluid particle is moving with 3 meter per second. अरे ये z direction में move हो रहा हूँ ना. This is z direction. Normal to the screen is z direction. Center line fluid particle assume करो ना. Assume करो एक pipe assume करो. ऐसा एक गोल pipe है. There is a circular pipe. There is a circular pipe. The fluid particle which is at center line, it will be having the velocity of 5 meter per second. उसके side वाला is having 3 meter per second. So 100% the velocity is changing in z direction also. अरे यस 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 यस, एक्सेलेंट एक्सेलेंट एक्सेलेंट, वेरी गुड वेरी गुड वेरी गुड वेरी गुड वेरी गुड। चलिए चलिए, एक्सेलेंट। जेड डायरेक्शन रिपीट कर दिया रे बाबा। अरे जेड डायरेक्शन, दिस इज द 2D डायग्राम, यहां पर नहीं दिखेगा, पर आर यू एबल टू अंडरस्टैंड? इफ दिस इज द सेंटर लाइन फ्लूइड पार्टिकल, इसके बगल में होगा ना। अरे जेड डायरेक्शन इज नॉर्मल टू दिस, नॉर्मल टू दिस स्क्रीन, तो इसके बगल में होगा ना जेड डायरेक्शन में एक फ्लूइड पार्टिकल। लेट मी से दैट फ्लूइड पार्टिकल इज हैविंग द वेलोसिटी ऑफ 3 मीटर पर सेकंड, सो 100% द वेलोसिटी इज चेंजिंग इन जेड डायरेक्शन आल्सो। उमेश, दैट आई एम नॉट सेइंग राइट नाउ, ये मैं प्रूव करूंगा, ये मैं प्रूव करूंगा उमेश, दैट आई विल प्रूव। मजा 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 मजा, एक्सीलेंट रमेश, वेरी गुड बेटा, यस, क्लियर क्लियर क्लियर। चलिए चलिए, एक्सीलेंट माय फ्रेंड्स, वेरी गुड, आई एम वेरी हैप्पी, आई एम वेरी हैप्पी यू आर एबल टू अंडरस्टैंड, मोस्ट ऑफ यू आर एबल टू अंडरस्टैंड। मैक्सिमम होती है कि नहीं होती है सेंट्रल लाइन में, दैट वी विल सी इन फ्यूचर, आगे देखने वाले। अब मुझे एक चीज बताना बेटा, अब ध्यान से सुनना, प्लीज लिसन केयरफुली। एक्सीलेंट, देखो देखो, in fully developed flow, each fluid particles in fully developed flow, each fluid particle moves at constant velocity along a streamline। जो fully developed flow होता है, in fully developed flow each fluid particle moves at constant velocity along a streamline and velocity profile remains unchanged in flow direction। जब flow direction में velocity profile change नहीं होता है, that means whatever the velocity profile I am having here, whatever the velocity profile I am having here, same velocity profile I will be having here. So in fully developed flow, remember, velocity profile will not change, I will be having the same velocity profile beta, I will be having same velocity profile, I will be having same velocity profile। Excellent, very good। Now listen carefully, there is no motion in radial direction। remember, whenever we are having fully developed flow, radial direction में motion नहीं होगा। what is the meaning of radial direction? in z direction, in y direction, in z direction, in y direction, in z direction there will be no motion, hence component of velocity in the direction normal to the axis is zero everywhere, hence component of velocity in the direction normal to the axis is zero everywhere। if the flow is taking place in x direction, that means normal directions are y direction and z direction, in y direction and z direction 100% your component of velocities will be zero। अब ध्यान से देखना बेटा, listen carefully, let us suppose on this axis I am keeping pressure, please observe carefully beta, please observe carefully, let us suppose on this axis I am keeping pressure, let me say this is the length, this is the length, let me say this is the length, this is the length of the pipe, distance, let me say distance from the distance in x direction, maybe something like this, of course let me say up to here, let me say up to here I am having developing region। so you can understand my friends, you can understand। अगर आप थोड़ा ध्यान से देखेंगे क्या बोल रहा हूं मैं, प्लीज ऑब्जर्व केयरफुली, प्लीज ऑब्जर्व द ब्यूटिफुल ऑब्जर्वेशन। so look at here my friends, what I'm trying to tell you is, what I'm trying to tell you is here, this is your developing region, 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 and 100% this complete is your fully developed region, this complete will be your fully developed region, fully developed region, fully developed region। now one interesting thing I want to tell you, one interesting thing I want to tell you, remember, whenever we are having fully developed flow, that means whenever the flow is taking place in fully developed region, remember the pressure will keep on decreasing, pressure will keep on decreasing because of the viscous losses, because of the viscous losses। तो ध्यान से देखना बेटा, how the things will look like, look at here, look at here, let me say here, I don't know what will happen in a developing region, we don't know about developing region, but 100% in this fully developed region, in this fully developed region, pressure will be decreasing linearly. Pressure will be decreasing linearly. That means what I'm trying to tell you is listen carefully. That means what I'm trying to tell you is listen carefully. Dou p by dou x, in the flow direction pressure will decrease, and since I'm having linear decrease, so dou p by dou x will be negative constant. इसको थोड़ा सा ध्यान रख लेना बेटा. Dou p by dou x will be negative constant. Dou p by dou x will be negative constant. ध्यान से देखो, मैं आपको एक एग्जांपल देता हूं. Let us see one example so that you can understand in a better way. Let me say this is one cross section. Let me say this is one cross section. This is another cross section. मान लीजिए मैंने दो cross section लिए. Let us suppose I have taken two cross sections. This is cross section 1. This is cross section 2. Then you can observe, my friends. Let us suppose the pressure at this cross section is P1. Let us suppose the pressure at this cross section is P1. Then if I'm moving from cross section 1 to cross section 2, you can observe pressure is decreasing from P1 to P2 linearly. The pressure will be decreasing from 1 to 2 at this cross section. If my pressure is P1, at this cross section if my pressure is P2, you can observe pressure will be decreasing linearly. So याद रखना, in fully developed region the pressure decreases linearly. If it is decreasing, then dou p by dou x is negative. Since it is decreasing linearly, I am saying dou p by dou x will be negative constant. Okay, ठीक है, ठीक है. Is it clear to everyone? Excellent. So look at here. During fully developed flow, pressure gradient is negative constant, since viscous effects takes the pressure to push the fluid through the pipe. So इसको बिल्कुल ध्यान में रखिएगा, बिल्कुल ध्यान में रखिएगा. In fully developed region, please keep in mind the pressure will keep on decreasing and pressure will be decreasing linearly. अब मैं आपको एक और चीज बताता हूँ. Now listen carefully. I will be giving you one more thing. Please observe बेटा. This is already asked in GATE exam. ये already GATE exam में पूछा हुआ है बेटा. This is already asked in GATE exam. Look at here. Let me say this is pipe. Now look at here. Of course, up to here, let me say I am having developing region. Up to here, let us suppose we are having developing region. So look at here beta. This is a developing region. Fine. This is a developing region. Fine. Now 100% here you will be having fully developed region. Here you will be having fully developed region. Now listen carefully. Let us suppose, ध्यान से सुनना बेटा. Let us suppose I am having steady and incompressible flow. ध्यान से देखो, whatever the flow is taking place through that pipe, this pipe, let me say that is steady and incompressible flow. Let's suppose through this pipe I am having a steady and incompressible flow. Let us suppose through this pipe I am having a steady and incompressible flow. Then anyone in the class can tell me, if I am taking one cross section here in developing region, if I am taking one cross section here in developing region, if I am taking one cross section here in fully developed region, let us suppose here in developing region the average velocity at this cross section, average velocity is v1. Let us suppose when I have taken one cross section in developing region, here the average velocity is v1, here the average velocity is v2. My question is very simple. Can you tell me which one is more, which one is less? v1 will be more or v2 will be more, or both are equal? What will be your answer beta? What will be your answer? Bolo re baba. What will be your answer? Boliye. I am waiting for your answer beta. I am waiting for your answer. Boliye. Equal, same. Excellent. Very good. v1 will be more, v2 will be more. Very good. I am getting so many answers. What about others? v2 will be more, v2 is more, v1 is less. Same. Okay, चलो बेटा देख लेते हैं. अच्छा, what is the meaning of steady flow बेटा? What is the meaning of steady flow? Can I say the meaning of steady flow is at any cross section, if I am having The study flow, you take any cross section, maybe in developing region or maybe in fully developed region. Can I say if I am having the study flow at any cross section, mass flow rate will be same? Mass flow rate will be constant for study flow. Mass flow rate will be constant throughout the cross section, or I can write mass flow rate is same. Mass flow rate is same at any cross section. At any cross section, you take any cross section of the pipe, mass flow rate is same. Excellent. Beta, what is the meaning of incompressible flow? What is the meaning of incompressible flow? Anyone in the class? Anyone in the class, beta? What is the meaning of incompressible flow? What is the meaning of incompressible flow, my friends? Yes, very good, beta. What is the meaning of incompressible flow? Incompressible flow का मतलब क्या होता है बेटा? What is the meaning of incompressible flow? What is the meaning of incompressible flow? Anyone in the class? What is the meaning of incompressible flow? Density is what? Constant. Throughout the flow, density is not changing. When the fluid is flowing from one cross section to another cross section, 100% density is not changing. अच्छा ये बताओ, whatever the pipe is taken, can I say that is uniform diameter pipe? Can I say that is uniform diameter pipe? Can I say that is uniform diameter pipe? जो भी क्रॉस सेक्शन मैंने अभी लिया है, can I say that is uniform diameter pipe? Whatever the pipe I have taken, can I say that is uniform diameter pipe? What is the meaning of uniform diameter pipe? What is the meaning of uniform diameter pipe, beta? What is the meaning of uniform by diameter pipe? That means everywhere the cross section area is same. Everywhere the cross section area is same. Everywhere is the cross section area is same. Everywhere cross section area is same. Now मैं आपसे एक सिंपल चीज पूछूंगा बेटा. What is the basic formula of mass flow rate in terms of average velocity? What is the relation between mass flow rate and average velocity? I have given you in fluid kinematics. I have told you what is the relation between mass flow rate and average velocity. So you know mass flow rate is equal to what? Rho AV. Rho AV. Then V is equal to what? Mass flow rate divided by what? Rho A. Mass flow rate divided by rho A. Mass flow rate divided by rho A. I hope you are able to understand. देखो, whether you take this cross section in developing region or this cross section in fully developed region, can I say this is same, beta? Can I say this is same at both cross sections? This is same at both cross sections. Whether you take one cross section here in developing region or one cross section here in fully developed region, 100% mass flow rate will be same because I am having a steady flow. Acha, can I say density will be same at both cross sections, beta? Can I say density will be same at both cross sections? Look at here. You take the density at this cross section or you take the density at this cross section. Because I am having the incompressible flow, can I say density will be constant? Yes, density will be same at both cross section. Now what is this A? This A is the area of cross section. Since I am having uniform diameter pipe, can I say whatever the cross section area I am having here, same cross section area I am having here? So 100%, can I say it will be same at both cross section? Oh my god, mass flow rate is same at both cross sections. I can say density is same at both cross sections. I can say average velocity is also same at both cross sections. So can I say with 100% confidence average velocity is the same at both cross sections? At both cross sections. So याद रखना बेटा, this is already a gate question. This has been asked in gate exam. So please understand what I'm saying. You take any cross section, maybe you take one cross section here, you take another cross section here, one here, one here, one here, one here. You take any cross section. If you are having steady and incompressible flow through uniform diameter pipe, 100% the average velocity will be same everywhere. That means, look at here. That means if the average velocity here is like this, ध्यान से देखना बेटा, if the average velocity here is like this, बिल्कुल ध्यान से देखेंगे, if the average velocity here is like this, v1, then the same average velocity you will be having at any other cross section. Same average velocity you will be having at any other cross section. If it is V1, then V1 will be exactly equal to V2. I hope you are able to understand the beautiful concept. I hope you are able to understand the beautiful concept, my friends. बोलो क्लियर है? Are you clear with this? Are you clear with this? Are you clear with this? I hope you have seen the fluid kinematics classes. जिन्होंने fluid kinematics की क्लास नहीं देखी है उनको थोड़ा प्रॉब्लम हो जाएगी. Those who haven't seen the fluid kinematics classes, they will be in little trouble because they are not aware of this. They are not aware of this mass flow rate formula. देखो, already I have told in my fluid kinematics classes, जिन लोगों को नहीं समझ में आया सुन लीजिए. I have already told in my fluid kinematics classes that mass flow rate can be written as density into cross section area into average velocity. कहने का मतलब है average velocity must be equal to mass flow rate divided by density into area of the cross section. Now whether you take this cross section, आप ये वाला cross section लो या ये वाला, क्वेश्चन क्या था? क्वेश्चन ये था, the question was this one. Let us suppose I am taking one cross section in developing region. Let us suppose I am taking another cross section in fully developed region. The question was, what will be the relation? Which one will be higher? Let us suppose in developing region average velocity is V1. Let us suppose in fully developed region average velocity is V2. Which one is more? Which one is less? Or they are equal? So 100% answer is they are equal. Why they are equal? Because in both cross section, अरे I have given you ना, I am having a study and ये condition है बेटा. I am having a study and incompressible flow. I am having a study and incompressible flow through uniform diameter pipe. The moment I am saying study and incompressible flow का मतलब क्या होता है बेटा? What is the meaning of study and incompressible flow? Mass flow rate will be same. So here at this cross section and this cross section 100% mass flow rate will be same, 100% density will be same, 100% cross section area will be same, and that is on what your average velocity is depending. Average velocity is what? Average velocity is equal to mass flow rate divided by density into cross section area. Whatever the mass flow rate is here, same mass flow rate is here. Whatever the density is here, same density is here. Whatever the area of cross section is here, same area of cross section is here. So 100% the average velocity will be equal. There is no doubt V1 will be equal to V2. There is no doubt beta V1 will be equal to V2. Is that clear to everyone? Bolo re baba, are you clear till here? Are you clear till here? Are you clear till here? बोलो रे बाबा, बोलिए यहां तक क्लियर है? यहां तक क्लियर है आपको? बोलिए आर यू क्लियर टिल हियर? बेटा बिमलेंदु कुमार मिश्रा, बेटा यही चल रहा है? नहीं बेटा, चेतन you see my classes on fluid kinematics. You will come to know. Even if we are having different velocity profiles, the average velocity can be same. कोई फर्क नहीं पड़ता बेटा. Chetan, doesn't matter. Even if we are having the different velocity profiles, we can have the same average velocity. कोई फर्क नहीं पड़ेगा. क्लियर है सबको बेटा यहां तक? Are you clear? Mustafa Sheikh is saying yes sir clear. Bharat Verma is saying yes sir clear. Mahesh is saying yes sir clear. Vinay is saying yes sir clear. बाकी लोग बोलिए. सतपदीप is saying yes sir clear. अभिनंदन is saying sir yes sir clear. चलिए एक्सीलेंट बेटा, एक्सीलेंट. अभी मैं जितना भी आपको बता रहा हूं ना, इफ यू आर एबल टू अंडरस्टैंड ऑल दिस थिंग, देन लैमिनार फ्लो का जब अंदर में घुसेंगे ना, इट विल बी वेरी इजी. ऑल दीज थिंग्स, लुक एट हियर, दिस इज गेट क्वेश्चन वी विल बी सॉल्विंग इन द क्लास. देखो ध्यान से. फॉर स्टडी एंड इनकम्प्रेसिबल फ्लो, एवरेज वेलोसिटी इन developing flow region and fully developed region are identical for uniform diameter pipe. अब देखो बेटा एक चीज और पूछ रहा हूं आपसे. Listen carefully. I'm asking you one more question. Please observe carefully. What will be the acceleration for study fully developed laminar flow? What will be the acceleration in x direction? देखना बेटा ध्यान से. Please observe carefully. Let us suppose I am having three directions. Let me say this is x direction. Let me say this is y direction. Let me say this is z direction. Anyone in the class, देखो अब ये ऑलरेडी अगर आपने मेरी फ्लूइड काइनेमेटिक्स की क्लासेस देखी है, देन ओनली यू कैन आंसर. I want to find what is AX. I want to find what is AX. Anyone in the class? Anyone in the class? If the flow is taking place in X direction, I want to find what is AX. What is the formula of AX? Anyone in the class knows about this? What is the meaning of AX, beta? In fluid kinematics, I have told you U dou U by dou X plus V dou U by dou Y plus W dou U by dou Z plus dou U by dou T plus dou U by dou T plus dou U by dou T. Now listen carefully. Listen carefully. Anyone in the class can tell me for a steady flow. For a steady flow, which term will be zero? For a steady flow, anyone in the class, which term will be zero? For a steady flow, which term will be zero? Anyone in the class? कोई बता सकता है for a steady flow which term will be zero? Yes, excellent. For a steady flow, dou U by dou T will be zero. Dou U by dou T will be zero. So what is the formula of AX I am getting? The formula of AX, if I am substituting dou U by dou T is 0, I am getting AX is equal to U dou U by dou X plus V dou U by dou Y plus W dou U by dou Z. Excellent, my friends. Now listen carefully. Very good, beta. Very good. Excellent. Excellent. Beautiful. I am very happy so many of you are able to answer because this I have discussed in fluid kinematics. अगर आपने देखें तो आपको समझ में आ रहा होगा क्या लिख रहा हूं. Now, for fully developed flow, anyone in the class, क्या क्या जीरो होता है बेटा? For fully developed flow, what are the things which are zero, beta? What are the things which are zero? What are the things which are zero? For fully developed flow, what are the things which are zero? Can I say for fully developed flow, V is 0? Can I say V is 0? Can I say V is 0? Can I say W is 0? Can I say dou U by dou X is 0? Can I say dou U by dou X is 0? Can I say dou U by dou X 0? 100% V will be 0, W will be 0, 100% dou U by dou X will be 0. Everything I have discussed earlier. For fully developed flow, fluid particle will not be moving in radial direction. That means in Y direction there will be no movement. In Z direction there will be no movement, and 100% velocity profile will remain unchanged in the fluid flow direction. That means dou U by dou X is 0. अगर ये सब मैं substitute कर दूं, if I substitute all these things, U dou U by dou X is 0, V is 0, 0 dou U by dou Y plus W is 0 dou U by dou Z. So what are we getting, my friends? What are we getting? Acceleration in X direction will be 0. Acceleration in X direction will be 0. Acceleration in X direction will be 0. 100% there will be no acceleration. 100% there will be no acceleration in X direction. There will be no acceleration in X direction. There is no doubt. There is no doubt. Acceleration in X direction will be 0. मैं आपको एक feel भी देता हूँ बेटा. Let me give you the feel also. Let me give you the feel also. Look at here. Look at here. Look at here. Can I say one thing? You take any two cross sections here. The average velocity will remain same, beta. Average velocity will remain same, na. You take one cross section here. You take one cross section here, or anywhere you take. Can I say the average velocity will remain same everywhere? अब देखो, आपको याद है? Do you remember? Do you remember? What will be the net force, beta? What will be the net force in X direction? What will be the net force in X direction? The net force in X direction will be equal to rate of change of linear momentum. That means final rate of linear momentum in X direction minus initial rate of linear momentum in X direction. Fine. So the net force in X direction, mass flow rate is same. Mass flow rate is same. Let us suppose I am taking two cross sections. Let me say this is the final average velocity. This is initial and average velocity. Of course, both will be equal, na beta. Both of them will be equal, na. Array, you take any two cross section. Can I say at those two cross section average velocity will be same? Yes. If average velocity is same, 100% this and this will be getting cancelled. If this is getting cancelled, then 100% the net force in X direction must be 0. If the net force in X direction is 0, what is the meaning of net force, beta? Mass into acceleration is 0. So of course AX will be 0, na. 100%. If the net force in x direction is 0, that means ax will be 0. Ax will be 0. I hope everyone is clear till here. Yes, yes, excellent. I hope everyone is clear, beta. Everyone is clear till here. यहां तक सबको समझ में आ गया? Yes, 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 Piyush. Everything is correct, beta. Yes, yes, very good, beta. Yes, Vidyanshu, very good, beta. Mahesh, very good, very good. I hope everyone is clear. यस यस नितिन, यस यस यस, ये तो होना ही था, ये तो होना ही था. अभी आपको फील आ रहा है. नाउ यू आर एबल टू अंडरस्टैंड ईच एंड एवरीथिंग. नाउ यू आर एबल टू अंडरस्टैंड ईच एंड एवरीथिंग. वेरी गुड बेटा. थैंक यू सो मच छापा रमेश. छापा रमेश, थैंक यू सो मच बेटा. मजा 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 मजा. वेरी गुड, वेरी गुड. आई एम वेरी हैप्पी. आज अभी तक जो भी पढ़ा है, आर यू क्लियर विद दिस? आज अभी तक जो भी पढ़ा है, आर यू क्लियर विद दिस? एक्सीलेंट. 100% क्लियर. 100% क्लियर. वेरी गुड बेटा. वेरी गुड नागा साई. एक्सीलेंट एक्सीलेंट एक्सीलेंट. वेरी गुड वेरी गुड. किसी को कोई डाउट है तो पूछ लो बेटा. आई विल बी आंसरिंग इफ समवन इज हैविंग एनी डाउट. इफ एनीवन इज हैविंग एनी डाउट, फील फ्री टू आस्क. एक्सीलेंट चंदन, वेरी गुड बेटा. वेरी गुड वेरी गुड वेरी गुड. व्हाट अबाउट अदर्स? व्हाट अबाउट अदर्स? इफ एनीवन इज हैविंग एनी डाउट, मस्त क्लियर. अरे वाह वाह, वेरी गुड ओमकार, वेरी गुड. क्लियर सर, क्लियर. अरे लाइक कर दो रे बाबा. सर व्हाट अ ब्यूटी, व्हाट अ ब्यूटी. एक्सीलेंट एक्सीलेंट. बेटा आज की क्लास मैंने बहुत स्लोली ली है बिकॉज आई नो fully developed flow is one of the difficult concept where students are struggling. They are not able to feel what is happening. They are not able to feel what is happening. That's why I have taken in very 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 slow manner. That's why I have taken in very 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 slow manner. Excellent 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 excellent. Very good very good. Yes yes. बेटा विवेक ओपन चैनल फ्लो का नहीं दिया मैंने बेटा. I haven't given for open channel flow. I haven't given for open channel flow. Whatever I have given, that is for flow through pipe. Whatever I have given is that is for flow through pipe beta. Oh Siva Soni, today is your first class. Oh my god, oh my god, oh my god. Okay okay. नहीं होता ना महेश. At entrance you will not have the well defined velocity profile. Let us suppose you are going to some class. Let us suppose you are going to your college. When you are entering the classroom, you will be wandering here and there to settle down. You will be wandering here and there to settle down. आप पहले सोचोगे यहाँ इसके बगल में बैठूं या उधर बैठूं बगल में या उधर बैठूं बगल में. So you will be wandering here and there. So initially the velocity profile will not be fully developed. Only after certain length of pipe the velocity profile will be fully developed. Yes Chandan, this is very tough topic basically. Yes, it is very 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 difficult topic. Yes. Excellent excellent. Thank you Chandan beta, thank you so much. Thank you so much. Siva Soni, if it is your first class beta, if you are having any doubt you can ask me beta. आपको जो भी पूछना आप मुझे पूछ सकते हैं. Tomorrow I am going to discuss about engineering services examination. Tomorrow I will be discussing about engineering services examination. डेवलप फ्लो क्या होता है बेटा? डेवलप फ्लो वो होता है जहां पर वेलोसिटी प्रोफाइल वेल डिफाइंड होती है एंड इट विल नॉट चेंज अलोंग द फ्लो. The velocity profile will not change along the flow. That means the situation is, let us suppose if you are having the flow in x direction, dou u by dou x will be 0. Raju, it will be getting uploaded beta. It will be getting uploaded. नहीं, वेलोसिटी प्रोफाइल चेंज नहीं होगी बेटा. नेवियर स्टोक्स इक्वेशन वी विल सी बेटा. नेवियर स्टोक इक्वेशन वी विल सी सम फाइन डे. इफ रिक्वायर्ड आई विल डिस्कस. अगर ज्यादा बच्चे होंगे तो वी विल डिस्कस. देन इट विल बी लिटिल डिफिकल्ट. अगर मल्टीपल क्रॉस सेक्शन के पाइप हैं तो थोड़ा सा डिफिकल्ट हो जाएगा सिचुएशन, वो आई विल डिस्कस. 6 PM प्रेम, 6 PM. थैंक यू सो मच प्रसाद. क्वेश्चन नहीं हुआ है, आई विल टेक, आई विल टेक. यस यस डेफिनेटली नेहा, नो प्रॉब्लम. एनीवन कैन क्रैक. थैंक यू सो मच ओमकार. हाँ, अरे यूनिफॉर्म वेलोसिटी उत्कर्ष, go through my classes of fluid kinematics, go through the classes of fluid kinematics. When we are talking about average velocity is the imaginary uniform velocity only. Chapa Ramesh, you contact me separately. There is no separate book for engineering sciences, beta. It will not change, beta. Velocity profile is remaining same. So 100% velocity will not change. Average velocity will not change. Pressure will decrease, beta. Whatever the losses we are getting because of that, pressure is decreasing. Thank you so much, Vinay. Thank you so much, Afridi. Thank you so much, beta. Velocity will not change. Renuka, velocity will not change. Velocity will not change. Pressure will decrease. Pressure will decrease, beta. बेटा जिनको मेंस के लिए प्रैक्टिस बुक चाहिए वो एक बार मुझे कांटेक्ट कर लेना. ओ वेरी नाइस.